In this lesson, I'm going to show you how to calculate the frequency of a generated wave on a string. Now, a string vibrator creates a standing wave as depicted in the diagram. The length of the string, L, is equal to 120 centimeters. The suspended mass is equal to 350 grams. The linear density of the string is equal to 0.0015 kilograms per meters. And it asks you to calculate the frequency produced by the generator. So what is the frequency? Well, frequency can be determined using the wave equation. V is equal to lambda times frequency, or frequency is equal to the velocity of the wave divided by the wavelength of the wave. Now, we can determine the wavelength from the information provided about the string, but the velocity is going to have to be calculated separately. So let's first deal with lambda. Now, we know that L is equal to 120 centimeters, but our wave only consists of two antinodes. So two antinodes makes a wave, so lambda is going to be equal to 2/3 of 120, because there are three parts here. We only need two, so 2/3 of 120 is 80 centimeters. Which is equal to 0.80 meters. So that's our wavelength. Now, I converted this to meters because we always deal in MKS units. Meters, kilograms, seconds. So we have our lambda. Now, to figure out what our velocity is, we're going to use the equation V is equal to the tension on the string divided by the linear mass density. Linear mass density is m divided by L of the string. So let's deal with the force acting on the string. So the force is caused by this mass. Now we're told that the mass is equal to 350 grams, and that's of course equal to 0.350 kilograms. Again, we're using MKS, in this case kilograms, instead of the grams. So if we draw a free body diagram, we see that the tension, Ft, is provided by the suspended mass. So since the mass is suspended, it's not moving up or down, it's just kind of vibrating up a little bit. We can say that Ft is equal to mg. So Ft is equal to 0.350 times 9.81, and that product works out to be 3.43 newtons. So there's our Ft. So now that I have our force and I have our information, I have our linear mass density is actually determined for us. We can calculate the velocity. So the velocity is going to be equal to the force, which is 3.43, divided by the linear density, which is 0.0015 kilograms per meter, and take the square root of that. And that's going to give us the square root of 2287. So the velocity is going to be equal to 47.8 meters per second. So the final step is going to be frequency is equal to velocity divided by the wavelength. Velocity is 47.8. The wavelength is 0.80. So the frequency is equal to 59.8 hertz.